Swayam Prabha. Digital India. Educated India.
So in the last module, we saw how to create data frames. So we had created a data frame DF. We are going to work with this data frame in this module and see what are the things that we can do in terms of accessing, changing of the data frames and so on. Data frames can be edited by direct assignment. For example, if you look at this data frame, vector 2, which is the second object in the data frame, has 3 elements. The first element is a string R, the second element is a string Scilab, and the third element is a string Java. For example, if you wanted to convert the Scilab to R, all you need to do is simply assign the second element of the second object as R. And we had already seen before, if you want 2-level access, you have to do the first level where you have 2 square brackets and the second level with a single square bracket, as we see here. So this is directly changing data frames from the console itself. There are other ways of changing the data frame using what is called an edit command. So here we show an example where we create a new table, my table, which is basically a data frame. So when you do that, the my table will be empty. You can then pull up my table with edit and add anything that you want. So you'll get this in a tabular form. You can give names, you can give numbers, and so on. So you get this table in the form that's of use to you. So this is another way of editing a data frame. Now, already defined data frames, all you need to do is simply say edit. So for example, if you wanted to do what we did in the last slide, not by direct assignment, but through the edit command, what we would have done is we would have said edit df, and then you would get this table, and then you can change any number that you want here itself. Now, as I mentioned before, all of these we are doing with the workspace, but there are also ways in which you can store these data in files and then bring them back into R. So you could have a data frame already defined in a file. You can bring that through this read.table and give the file name, and that will define your data frame that you have. So you don't have to always define data frames on the go in the console. You could use already defined data frames which are stored in files, bring them to your session and work with them. Now, much like how we talked about accessing lists, you need to access data frames, and the syntax is very, very simple. If you just give only one value and access it, it always refers to a column. So for example, if you just said df1, it will refer to the first column. But if you had 2 elements separated by a comma in the way you're accessing, then it would mean row followed by a column. So in this example, the first command we have, which is df, which first entry is 1:2, comma, nothing, square bracket close. The command, the syntax here is that I want to access the first and second rows of df and all the columns. And you see the result here. You get the 2 rows, and the third row is missing, but every column is seen in the result on the console output. Now, if you wanted to do the opposite, you wanted to access only the first and second columns and all rows, what you do is you do a comma without anything before that basically says take everything, and the second one says you take columns from 1 to 2. Now, this need not be just 1 to 2. If you had, let's say, 100 columns, you could say 5 to 20, you could say 1 to 5, and so on. So it'll basically take whatever columns that you're defining that you want to print out and then show you the columns. Now, you could also directly assign different columns. So for example, if you had another data frame which was of the size that is shown on the first top of the console output, you can directly assign that to data frame 1:2, comma, close square bracket. That is what we are showing here. you can add extra rows and columns using two functions. One is called rbind, which will help you add extra rows, and if you want to add extra columns, then you use what is called a cbind. Okay, so it's very simple. As we saw before, the sizes have to be the same, the types have to be the same. So for example, in the data frame df, if you wanted to add another row, we already know that we need to have at least 3 elements because each row has 3 columns. We not only know that, we also know that the first element has to be an integer, the second element has to be a string, and the third element has to be a string. So if you were to do an rbind with df and a data frame, which has the first element as 4 integer, second element c string, third element for scalar, and then just do rbind, you will see that a 4th row has been added in the right hand side console output, which is 4c scalar. Very similarly, you add another column. But now when you add the column, because each column has to be of the same type, all the elements have to be of the same type. So if by looking at the code here, whenever you cbind, there's a 4th column that is being added, and within that 4th column, all elements have to be of the same type. In this case, all elements are integers that you see here. So the result is seen in the console output. You have an extra column with these integers 10, 20, 30, and 40. Very similarly, you can delete rows and columns. Very simple. For example, if you wanted to delete third row and the first column, you have a comment which says df minus 3 minus 1. Basically, minus would delete whatever corresponding row or a column. You can also delete only a few with a single command. So we show here the command is which is shown in the screen is df4, which basically says any data frame row which has a number 3, you delete it. Everything else you retain. That is how this exclamation is there. And when you look at the console output, if you look at the top, you have 1 R 10, 2 Scilab 23, Java 34, C 40. Now, if you want to delete specifically only 3, you can do the command and then you will have your third 3 getting deleted. Now, there is an interesting thing with data frames. When you define integers, the program knows the whole set of integers. When you define double a float, the program knows all floats. But when you define strings, the program does not know all the strings. So what R does is it assumes that whatever strings have been developed, those are the only strings that are possible. So here we show an example where, let's say, the same data frame, we want to add a new element, which is 3 element, which is I'm going to call as strings others, and then try to do it. If you see the result on the right hand side, it says not applicable or not available. Basically, this is because when I defined my vector 3 before, the only types were for prototyping or for scalar. Now, if you had said this is, instead of others, if you had said for prototyping or for scalar, it would have done it, because that's the only thing that R knows as that element type. Since you did others, it puts NA. So this is an interesting thing that you need to remember when you do coding with R. There is a way to get rid of this in R, where you use this command strings as factors as false. Basically what this says is, I can give you any string, just take it. Don't take only strings that are predefined. If strings as factors is true, then I am restricted to only taking strings that have been predefined. When strings as factors is false, then I can take any string that I want. Now if you use the same command, df33 equal to others, and look at the results, it's not NA anymore. You see that others has come into the result. Now, very similarly, you can just get subsets of data from a data frame. Here we are going to define a new data frame. So this data frame again has, we have name, there are 3 names, Sendil, Sam. We have month, which is Jan, Feb, and we have blood pressure and blood sugar data here. So we have this data frame that we are developing. Now what we are going to do is we want to pick only a certain subset of this data frame. So here what we are trying to do is we are trying to pick only a subset which has name Senthil and blood sugar numbers greater than 150. And if you look at the result on the other side, the first row has been picked up because the name is Senthil. The second row has been picked up because the name is Senthil. The fourth row also has been picked up, though the name is Sam, because we are picking a subset in terms of either name is Senthil or blood sugar is greater than 150. If you look at the number for blood sugar is 160.1, greater than 150. That is the reason why that has been picked up. So what this allows you to do is it allows you to take big data frames and then be able to get subsets based on any query that you are interested in.